way to see what's inside of what the NES hardware is than opening the thing up itself. And so, let's do this. Always remember to keep a can, or anything, I just use a can to recycle, to keep your screws that you're not using. Right now, I'll get onto it. Of course, this was before Nintendo when all security crazy started using security screws. We'll need a Phillips screwdriver. And of course an NES. So yeah, I've explained briefly in the last one. Of course, this isn't going to be the actual programming tutorial for today. It's going to kind of be a mini episode. Because I have a lot more important stuff that actually relates to programming. Just Gotta keep your screws in the can. Hold on. I'll be right back once I open it up. Inside the NES, and we see the 72-pin edge connector, which is, this is where you hook up your cartridge. Normally you would see a RF metal shield before this. You can just unscrew that. I already took mine out. Yeah. This is, pretty basic explanatory. This connects the edges on the pins on the cartridge onto the NES, so that, it can read everything. Now, we will have to remove this, and then so we can see the rest. One thing I've noticed, though, is that my edge connector is really bent from pushing and pulling down really a lot. That's what happened. That's one of the design flaws of the NES. That's why you had to blow in the cartridges, is because pushing the cartridge in, pushing it down, pulling up, pushing down, pulling up repeatedly, that was bad, because that was bad for the pin connectors, because it wore them out of constant force. I don't know if the Famicom had that, because that loaded the cartridges on the top, and it didn't have to bend anything. Yeah, that's one of the design flaws of this. So, if you have a problem with cartridges not booting up, then I recommend you get these. You can buy them on Amazon for like $10. So yeah. And when removing this, your instinct might be to pull this tray off. You're actually supposed to do the opposite. You're supposed to pull the edge connector off by pushing it off, because it's basically two edge connectors, and there's another and there's pins on the bottom, on the actual motherboard, and so you've got to pull it back off of the, well, I'll show you when I do it. There we go. I've removed the edge connector, leaving me the bare motherboard with the, pin connector, much like the one in the cartridge. As a matter of fact, I believe that it might even have the exact same pin out. It has to, because, this is what it is, basically. Hook the bottom right there, and the front goes there, and yeah. So yeah, now you just remove the screws like this, and then we can see all of the hardware that gives the NES its magic. All right, now here is the actual motherboard. pretty. So yeah, this is an NTSC version, meaning it's in the American. That's the RP 2A03 Rico 2A03 CPU. It's the American version. I'm pretty sure it's something else in Europe. No. And this is a 2CO2. This is the graphics that does all the graphics PPU. In the European, if you live in the European regions, then you'll see a Rico 2CO7. That's the lockout chip. I've removed that pin so that I can play games from all across the world without, because it's basically when this was released in 1985 in America, well, it was released in 1983 first in Japan. It didn't have region locking. Anyone could make games on it. When they wanted to sell it in America, though, since E.T. was such a bad game, the entire video game industry was kind of failing, and nobody wanted anything to do with video games. And I feel like the reason of that was because anybody could make games. So they made this custom chip. That only Nintendo had. And only Nintendo had the rights to manufacture, and nobody knew about it. And so they had to get the games to get approved by them, and then they would put the chip in the cartridge so that they could play it. And if they didn't have the chip, then the game wouldn't boot. And sometimes the pins don't work up with that, and so it does that. That's why the screen sometimes blinks gray, because it's not communicating with that. These are the controller ports. I think these capacitors are used to debounce them, so that because when you hold it button, it goes on and off really fast. It's not fast enough for our brains to notice, but computers are fast enough to notice. So it has that, so it stores the charge, and then so it doesn't go off unless it's not being held at all. And I think these are the two shift registers that read the controllers, because they're each 8 buttons for each 8 bits. Each button is a bit, I think, and this is the these are for the 2 player ports. I think so, because are they hooked up? No. I think those are, no, it can't be in there though, because I think those are resistor arrays. But this connects the video, audio, and power to the thing. And this socket, I don't know why it was used. It's might not, what is that? Well, it's not a Famicom cartridge slot. I think Nintendo originally wanted it to be a expansion plot, because the Japanese Famicom had a Famicom disk system, but so I think they were originally going to plan to have that, and you could hook it up through here. But I think the problem happened because pretty much anyone at the time could write to a floppy disk, and since they had the lockout chip so that nobody could pirate games, and so this would be so no one could make bad games without licensing them, and since anyone can write floppy disks, this would have been bad. I mean, they didn't remove it though for some odd reason, but they covered it up on the back of the case. I've destroyed it to reveal it, because you used to have a box you would have to remove, and then it would be covered with a piece of plastic. You'd have to remove it with a screwdriver to see it. Yeah, that's odd. What other chips do I notice? That's about it. So, don't worry, this is not replacing my normal one, so I'll be back later.